I am Tushar Bhatt from Science and Humanities Department, Atma University, Rajkot. Behalf of the Atma University, we welcome you all in our video lecture series. Today, we will going to learn the concept of calculus, and that is indeterminate forms. So that indeterminate forms and like such topic will be bridge between the 12th science mathematics and higher engineering mathematics. So we review the calculus as a form of indeterminate forms and discuss about the some methods to evaluate the limit of given functions. So we can start to understand what is indeterminate forms. So first we discuss about the what is limit. Let f of x be any function. Let f of x be any function and limit of f of x is denoted by limit x tends to a f of x equal to L. Limit x tends to a f of x equal to L. So that notation says that it means that when the difference between x and a is near to the 0 means delta, we read as delta. Follows the positive difference between fx and L, positive difference between the function and limit L is less than epsilon. So we read as epsilon. So definition says that the variable x is approached to a when the function f of x is approached to L. So that positive difference between two quantity is near to the 0, delta and epsilon both are the real numbers near to the 0, and that positive difference between f of x and L that also near to the 0 value means there is a minor difference between f of x and L near to the 0 means epsilon. So that is saying the definition of limit. So how to evaluate the limit? Our next question is how to evaluate limit. So that answer is the evaluation method for example, suppose we want to find limit x tends to 2 x square plus 4, x tends to 2 x square plus 4. So that is equal to, we are directly substitute the value x replaced by 2. Why? The given function does not having any denominator. Denominator is 1. So therefore, when we substitute x equal to 2, that function given a finite answer. So there is no need for further factorization. So substitute x equal to 2. So that is 2 square plus 4 is nothing but 4 plus 4 equal to 8. So that is the first case when given function doesn't having any denominator. Suppose the function having some denominator like that, limit x tends to 2, x square minus 2 upon x square plus 2. So what is the evaluation method? Evaluation method says that substitute x equal to 2 directly, but the denominator is not equal to 0. When the denominator is equal to 0, we can't substitute limit x tends to 2 directly. So we first check the denominator at the point 2 is not equal to 0. So that answer is not equal to 0. Then and then we directly substitute x equal to 2. Otherwise we can factorize and cancel out those factors who are having 0 value in the denominator. So here we observe that when we substitute x equal to 2 in the denominator becomes 2 square 4, 4 plus 2 6, and 6 is not equal to 0. Therefore we can substitute directly x equal to 2. So that is 2 square minus 2 upon 2 square plus 2. So 2 square is 4, 4 minus 2 upon 4 plus 2. So that is 2 upon 6, and that becomes 1 upon 3. So that is finite limit. Case number 3. Suppose we are having that fraction of the form limit x tends to 3, x square minus 9 upon x minus 3. X square minus 9 upon x minus 3. So here observe that when we substitute directly x equal to 3, then denominator becomes 0. Here substitute 3, 3 minus 3, 0. So denominators becomes 0, therefore answer becomes infinite. Therefore we can't substitute x equal to 3 directly. So that factorization is required, and x minus 3 factor is cancelled out with numerator if possible. So we check it. So that limit x tends to 3 as it is. The factorization of x square minus 9 according to the difference rule. So that becomes x minus 3, x plus 3 upon x minus 3. So x minus 3 will be cancelled out, and we have limit x tends to 3, x plus 3. So here denominator is 1. When we substitute x equal to 3, so denominator remains unchanged. Therefore we are directly substitute x equal to 3 in the given function. Hence we get 3 plus 3 equal to 6. So there are many ways to evaluate the limit of given function. I'll take another example. Since that sometimes we are using the familiar facts of limit. Suppose we want to evaluate limit x tends to 0 sin x upon 2x. Sin x upon 2x. Here observe that the limit x tends to 0 sin x upon 2x. In this case, first we are substitute directly x equal to 0 in the numerator. So we get answer 0 because sin 0 equal to 0. Substitute x tends to 0 means x equal to 0 in the denominator. We also get 2 into 0 equal to 0. So that also becomes a 0. But we are using a fact. We know that limit x tends to 0. I write again by this way, 1 by 2 into sin x upon x. So 1 by 2 is constant out of the limit process. So that is 1 by 2 limit x tends to 0 sin x upon x. Hence we know that the limit x tends to 0 sin x upon x is 1 according to the facts of limit. So that is standard formula of limit. Limit x tends to 0 sin x upon x is must be 1. So we get answer 1 by 2. So in such cases we observe that the evaluation method, when given function does not having any denominator, then we are directly substitute the limit. Suppose given function having some denominator, means a function in the form of fraction p by q. In this way, we are directly substitute the limit if denominator is not equal to 0 at the point x equal to 2. Here, denominator becomes a 0 at that point x equal to 3. Then we can factorize the numerator and cancel out the common factors. Hence, we get those function in the form of only numerator, denominator is 1. Then we are directly substitute the limit. By using the facts of the limit, here what we are using the facts, this fact is limit x tends to 0 sin x upon x is 1. Then, so according to that fact, we are using this result and here directly substitute 1 and we get finite limit. So that is the procedure to evaluate the limit of given function. There are several cases, but our requirement is only 4 cases to understand how to evaluate the limit of the given function when given function does not having numerator, given function having finite numerator, given function having 0 denominator, and apply the formula of limits or the facts of limits. So there are the cases. Now suppose